Hi everyone, welcome to this video. In this video, we will understand projectile motion in bit more detail by taking help of Microsoft Excel. I have created another video where I have covered the basics of projectile motion. So you will find the link of that video in the description section of this video. So if you are new to projectile motion, then I would urge you to watch that video first. Now if I ask you, how would the horizontal distance covered by this projectile change if I change the angle of release? What would your response be? Will the horizontal distance increase with increase in angle or will it decrease? You can pause this video, think about your response, and then resume this video. Alright, so I hope you would have given a thought to the above question. So we will visualize that relationship between the distance covered by this projectile and the angle of release with the help of Microsoft Excel. So before we start, let's have a quick recap of the basics of projectile motion. So in this projectile motion, as you can see here, the initial velocity is u. The angle of release, or in other words, the angle which the initial velocity makes with the horizontal is theta. The vertical distance covered by the projectile is BC, and the horizontal distance covered by the projectile is OA. So this is the path of the projectile. And the time, let's say the time which this projectile takes to reach from point O to point A is t. So at t is equal to 0, the projectile is thrown, and at t is equal to capital T, the projectile reaches capital A. Now, at any given time, the x position of the projectile is given by u cos theta into t, because in the horizontal direction or x direction, there is no acceleration. So the distance would be simply velocity into time. So velocity would be the component of u in the horizontal direction. So x will be u cos theta into t. And at any point of time, the y coordinates would be u sine theta t plus half gt square. So this is basic kinematics. Now do note that in this projectile, the value of g will be negative because the g is in downward direction. And as you can see, the y-axis is in the upward direction, so g will be negative here. And the time taken by this projectile to reach from point O to point A will be 2u sine theta by g. Now let's move to Microsoft Excel. So in this Excel spreadsheet, you can enter the initial velocity here. You can enter the angle of release and acceleration due to gravity. Now based on the entered values, you will see the projectile path. If you change the values of these parameters, the projectile path will change. So let's say if you decrease the initial velocity from 60 to 40, you can see the projectile path changes and the distance covered by the projectile also decreases. Now let's keep the initial velocity at 40 and let's change the angle to understand how the horizontal distance covered by the projectile changes. So here uh, my angle is 15. So let me now increase the angle to maybe 20 degrees. So you can see the horizontal distance increases to around 105 meter. Let me increase the angle of release to maybe 30. So you can see the distance further increases to roughly around 140 meter. Let me increase it to around 45. You can see the distance increases to around 160, 163 meters. So the distance further increases. The horizontal distance continues to increase as I increase the angle. Let's see whether this trend continues. So let me now increase the angle of release to maybe 50. So here you go. Here we see that, oh, the angle of the distance covered actually decreases slightly. At around 50, the distance decreases. Did you observe? Okay, so let me increase it further. Let me increase it to 60. Now you see the distance decreases. If I increase it to 70, the horizontal distance decreases even more. So what do we observe here? So we see that the horizontal distance increases initially as the angle of release increases. It happens till about 50 degrees sort of angle of release. Beyond 50 degrees, the horizontal distance starts to decrease. So that's how the horizontal distance change. Did you guess the same initially? Awesome if you guessed it right. So you can create this spreadsheet very easily. Let me explain briefly how I created it. So here I have a table where I have captured the input parameters. So here I have a cell, I have a row for initial velocity, angle, and acceleration due to gravity. Now, based on these input parameters, these values are computed. So here you might say why I have put angle again here. Well, in physics, for most of the calculations you do involving angle, you need to take the value of angle in radians. So here essentially what I've done is I've converted this angle from degrees to radians. Then you have time of flight. So we saw the formula of time of flight, which means the time it takes for the object to reach the cover the cover the full distance of the projectile. So that we saw it was 2u sine theta by g. So it is 2u sine theta by g. So based on the values, this time of flight is calculated. And then here you have time step. So what is this time step? So what we have done is we have divided the time of flight in 200 equal intervals. So if you divide, let's say 7.66 into 200 equal intervals, you will each interval would be of 0.04, roughly 0.04 seconds. Now at each time interval, we have calculated, or rather we have calculated x and y position, and based on the x and y values, this graph is plotted. Now, why I have taken 200, you may ask? Well, it just gives enough data points to plot a smooth curve. You can take 100 as well, or you can take 300. It's purely up to you. So this is the table where the actual x and y values are computed. So here we have three columns, time, x, and y. So as I told you, we have divided time of flight into 200 equal intervals. So here are the 200 time steps. You can see, so this 7.66 seconds has been divided into 200 time steps. So as you can see, the initial time is 0, and at first time step, it is 0.04 second. At the second time step, it's 0.04 plus the time interval, which is 0.08, and so on. Now at each time step, at each time interval, we have calculated the x value and y value. So x value, if you remember, was u cos theta into t. So we have u, C4 is for u, and then cos theta, cos of the angle into t. So t is g6. So we have put the formula to calculate the value of x, and we have accordingly put the formula to calculate the value of y here. And so you fill the values in one of the cells and then you drag till the last time step. So you get this table. Now to plot this graph, what you need to do is, so in this graph, as you can see, this horizontal axis is the x-axis, which uh, kind of denotes the x position of the projectile, and y-axis denotes the y position. So I have taken these two columns, x and y, and I have I went to insert, then I went to scatter plot, and in the scatter plot, maybe you can choose this. You have a bunch of options. So if I choose this option, so this is very close to the graph I had. So that's how you plot this graph. So give it a try. Try it yourself. It will be fun. Play with different values of u and theta and see how the path changes. So that's all we had in this video. Thanks for your time.